Today we are going to be looking at a couple of things, but it's a lot. And that has to do with one, we've looked at, I think for the past 1 week or past two classes, the last two classes we've looked at requirement specification, or should I say solution requirement specification, using use case specification and user stories, right? So we want to also look at the other part of solution requirement, which is non-functional requirements, to understand what are examples of non-functional requirements that we have. And then we now conclude the class by looking at how do we prioritize requirements and what are the attributes or characteristics of a well-written requirement. So when we write our requirements, how do we evaluate to know we have written a good requirement? For user stories, we've already mentioned that we use invest, but we also get to know other metrics that we use to evaluate different types of requirements. So we'll start by first talking about non-functional requirements. Just as the name goes, non-functional. They are basically requirements that speak to the non-functionality or conditions or quality of use of a solution. They are not speaking to, this needs to be, they don't speak to things like functionality or features or buttons or functions or activities that need to be carried out on the solution by users. Right? They're talking about conditions that needs to be in place for users to be able to make use or access a particular solution. So non-functional requirements describe how a system must behave and also establish constraints on its functionality. This type of requirement is also known as system quality attributes. Let me give you a background example that you can easily relate to. If I may ask, you wrote your JAMB or WAEC in Nigeria, right?
Yes.
Did you ever notice anything like when they say the WAEC or JAMB portal is down during the point of registration? They say their portal is down or their website is down. Have you encountered something as such? Are you there?
Yes, I said that happens. Yes.
And okay, that is an example. It's not that particular issue is not a functional requirement issue. It is a non-functional requirement issue, quality of service. That particular solution, that is a JAM portal or WAEC portal, is currently down because of the amount of user engagement or interaction or activity or traffic that it is experiencing within a short period of time.
Mm.
Do you understand? And that is
Yeah.
because before now, many people solutions are built without putting into consideration non-functional requirements. They just build them and say, we want this functionality, and they go ahead to build. They don't cater for the fact that what if we have an extended traffic, more than what the system can accommodate? What can the solution do? In the case of non-functional requirement will tell you that we should do what we call scalability. Scalability is the ability of a solution, right, to expand, to extend, to scale in order to accommodate additional traffic or load without breaking. Are you following me? So
Yeah.
most of these non-functional requirements, there were no business analysts to work with engineers on those solutions. You just got a consulting company, JAMB or WAEC, or outsource the development work to them. The outsourcing company don't even have what do you call it now? A BA within their team. I remember first job I got as a BA after my training. I worked with a fintech company. The company was into building financial solutions for tier one and tier two financial institutions, that is banks in Nigeria. Most of most of the tier two banks in Nigeria were using the core banking solution of that particular company. Now, when I joined the company, they had about let's say 50 something staff. Of these 50 something staff, 45 are software engineers. Five are just documentation engineers to help document their to help prepare user manual. There was no QA, there was no BA. Now, when I joined and I told them that when I went for the interview, I remember telling them that I want to be a business analyst. And they were asking me, what is the duty or what is the responsibility of a business analyst? How can you help us? I had to now give them an explanation of what or who a business analyst is. And based off that, when I came on board, I realized that I was the only BA. So I made it the 51st employee, and out of 51 employee, I was the only BA. So that goes a long way to tell you that 20 years ago, 15 years ago, 10 years ago, many companies don't even understand what business analysis is, right? Unlike now that business analysis is something that people now understand and sees the importance. And most solutions that were built back then were failing a lot. They were having multiple issues, performance issues, reliability issues, scalability issues. And that is because there was no BA in the team to guide the team in terms of what quality of service requirements should the solutions have. So there are different types of non-functional requirements. We have performance, we have scalability, we have compatibility, we have security, we have usability, we have availability, so many of them, right? In short, in the BA world, we call non-functional requirements the elitist requirement because many of them end with elite. So we call it the elitist, right? So these are non-functional requirements. And we'll take a look at them one after the other, starting with usability. Usability basically relates to how easy it is for users to make use of a system. There are some applications that you would download on your mobile phone for the first time, and you don't even need anybody to guide you on how to make use of it. You can easily pick up and start using it, right? Whereas there are some other applications that you download or install or you come across for the first time, and you actually need someone to guide you on how to use it, or you need a user manual to guide you on how to make use of that particular application. And that is because the usability of that particular solution is very poor, right? And the key things that we use to measure or track usability is things like learnability. Is it easy for users to learn how to use your solution? Efficiency, how quickly can users reach their goals? If a user wants to perform a transaction with your app, how is it for users to perform that transaction? Memorability, how easy can users return to your app or to your solution after some time and start efficiently without having to get a guidance from you? Another one is also errors. How often do people make mistakes using your application? And satisfaction, how delighted, how pleasant are, are your users or customers after making use of your what solution? An example of usability requirements would be users should be able to find their desired products within 3 clicks from the homepage. And this is what companies like Amazon have put into consideration. If you go to Amazon and you want to buy something today, you realize that with just 3 clicks, you should be able to purchase something on Amazon. Let me give you let's take a look at an example here, right? So let me open another browser and then pull up Amazon here. So here's Amazon, right? So within 3 clicks, you should be able to buy something on Amazon. So let's say I want to buy this item. This 1 click, right? Oh, there's something I want to buy. This is categories. Let me go to a particular item. I want a particular item. Okay, let me buy. I want to buy this book. I select this, right? One, this is the book. I click on buy now, right? Had it been I have an account, it will take me straight to what? Checkout. And then I click
Yeah.
checkout. 3 clicks. With 3 clicks, you are able to buy something on Amazon. And this is what top companies implement in their solution to ensure that their solutions are usable. So this is an example of usability requirement that you can write for a solution, because that is the average click span or retention span of users when using an application. If you need to buy something from Amazon and you need to click like almost 7 times before you get to your checkout, they call it churn rate. You will drop off. You will drop off from completing that particular activity. Another one is reliability. And reliability often talks about how often the system experiences critical failures. So how often is it that the system fails? There are some websites when you open them, you see 404 error, page
Mm.
not found. These are reliability issues. It means that the system fails frequently. So it explains how likely system or elements would run without a failure for a given period of time. So when we are writing a reliability requirement, we are making sure that we are making sure that we are putting in place measures that will allow our system to run without any form of downtime, right? Or so not downtime basically, without any form of failure that is kind of breaking, right? Without any form of breakage, like getting all of those 404 error, page not found or whatever not found. Another one is performance. Performance speaks to speed, how fast your solution is. You agree with me that there are some websites that you are going to open today. We can try it here. There's some website that you open, and by the time you open those websites, you click on those websites to load them, it takes a lot more time to load compared to others. Let's go back and try Amazon again. And let's count how many seconds it takes to open Amazon. So I'll click on this and let's count. 1, 2, within 2 seconds, right?
Mm. Yeah.
Now let's try another website. Let's try Jira, right? So I'll click it and we'll look at it. 1, 2, 3, 4, 5 within 5 seconds. Now Amazon has a high performance efficiency than Jira, which is basically the sum of it, right? And that's because Amazon itself is a bigger organization than Jira. But that doesn't mean that Amazon has lesser user activity. In short, Amazon has more user traffic and activity than Jira, right? Because the whole world is going on Amazon to take a look at their products to purchase. And Amazon has much more database than Jira. Sorry, give me a moment, please. My gate man is calling me.
Okay.
All right, can you hear me? Zolfa, can you hear me?
Yes, I can.
All right, thank you. So you can see that the performance of Amazon is higher than that of um, Jira. Even though Amazon have a larger user traffic, engagement, data storage, and whatever, the performance varies. Same thing if you look at different websites, the performance all varies. So performance speaks to how fast our system returns results, right? Just like you mentioned, the landing page supporting 5,000 users per hour must provide a 6-second or less response time in a Chrome desktop browser, including the rendering of text images over an LTE connection. This is an example of performance requirements. How fast does there's some applications that once you select something, it takes time to load before you see your next screen. That shows you that that particular solution or application have a lower performance compared to other applications. So we as business analysts, we write these performance requirements to help engineers understand how to enhance the performance and also quality of use of software solutions. Another one is security. Security is a very popular one. And this talks about how safe or protected our data is against attackers or against cyber attacks or cyber criminals, right? And there are so many things about security. We have the GDPR in the Europe and also Western worlds. We have in Nigeria, we have the NDPR. We also have the ISO 2701, right, which talks about data security for organizations who basically obtain um, process obtain and process user data. And then we have another one called accessibility. Accessibility requirements is a non-functional requirement that have taken prominence over the recent years. 20 years ago, many people don't really fancy what accessibility requirements is. A good example of accessibility requirements that we have today is like your dark screen. Do you understand? Your dark screen, that's whereby you turn on dark screen because of so much brightness, or you reduce the quality, the amount of blue light on your screen. Another one is things like text to speech, right? When text to speech is another type of what they call it now, accessibility requirement. Another one is caption. When you're watching YouTube videos, you'll be able to see captions on the audio conversation or the audio information that the content creator is actually passing across to you. And then we have scalability, like I made mention of the JAMB or WAEC example, ability for your solution to perform in a condition whereby there's a change in workload. There's an increasing demand of workload or traffic on your solution without it failing, right? That is what we call scalability. Ability for your servers, your database to scale and accommodate higher traffic or workload without breaking, without um, running down. That is what scalability is all about. Example of scalability is that the website must be scalable enough to support 1 million visits at the same time while maintaining optimal performance. Another example is that the real-time locating system should be able to scale from managing 10,000 to 500,000 IoT devices without loss of data fidelity or monitoring capabilities. So these are examples of scalability requirements. All you need is just to understand what these are, then you'll be able to communicate appropriately to the relevant thing. And then the next one is portability. Portability is mostly used when we are building a hardware solution, right? Or we are building a software that needs to run hand in hand with this hardware solution, right? That is where we talk about portability. For instance, the app should be operable and maintain a consistent user experience across multiple devices. Then we have compatibility, which talks about how the system, which talks about in places whereby how a system can coexist and interact with another system in the same environment. In the same environment, right? So there are some applications that you want to install in your phone or on your laptop. They will tell you that your operating system does not support this particular application. It's not compatible. right? Compatibility is a common word that is used when people are probably say dating or looking for a life partner. Say, no, we are not compatible, right? And also in software requirement or solution requirement, compatibility comes in because we need to make sure that whatever solution we are building, we ensure that it is compatible with what we are doing. There are some, for instance, I don't know if you've experienced it before. Back then, when I do, let me not say when I do use Android a lot, looking at 7 years ago, there are some applications that I will be installing, and then my mobile phone will give me a notification and say that this app is not compatible with my Android operating system, that I'll need to upgrade. Even aside that, you agree with me that there's no way you can install an iOS application on an Android device. They're not compatible. You get an error message to tell you that it's not compatible. Or you try to install a desktop application, maybe your Microsoft Word that you have on your desktop, the desktop file, you try to install it on your mobile phone, or you try to install an Android or iOS application on your desktop, you realize that they are not compatible because of the varying operating system differences. Another one is availability. Availability talks about how long is the average system downtime. And this is a very important requirement that we need to always consider when we are talking about non-functional requirements. Readily available are how readily available is our system? Is it that there's a lot of downtime? There are some applications that when you're trying to process payments, they'll tell you that we are experiencing system downtime due to too much traffic. And also, this is also something that's common with our financial apps. Sometimes you get a mail from them and they'll tell you that there will be a system downtime from this point to this point because you are doing a bit of system upgrade and transactions might not be processed efficiently. Okay. Then the next one is maintainability, which talks to how much time does it take to fix the issue when it arises. So whenever there's an issue, and this is where things like SLA, service level agreements, come to place. Whenever an issue or problem arises, how much time do we take to resolve it so that our system or our solution could be up and running for our customers or users to make use of it? Now, the next requirement that I'll be looking at is how then do we now prioritize requirements? After we have specified this requirement, and this is a very big problem, a very big issue for a junior BA or for a mid-level BA who don't really have so much understanding on what to prioritize or what the engineering team needs to focus their time and effort into. But before we go into prioritization of requirements, I don't know if you have any question regarding non-functional requirements. Is it were you able to understand or follow along, or do you need clarification in some
No,
place?
it's okay. It's clear.
Okay. So please put it at the back of your mind that you need to always represent non-functional requirements in your requirement documentation or your requirement documents. So we have two common types of requirement documents that business analysts write. Number one is business requirement documents, which is popularly called BRD. And then number two is functional requirement documents. And number two is functional requirements documents, which is called FRD, right? The business requirement document is written for business stakeholder audience, while the functional requirement document is written for the technical audience. Okay. Now,
Okay.
these are the two requirement documents. We're going to take a look at them in another class. Okay. I just thought to mention it here. Some people also call it BRS, Business Requirement Specification, or and also FRS, Functional Requirement Specification. Okay, they are the same thing. BRS, BRD are the same. FRS, FRD are the same. Okay.
Okay.
So
Okay.
yeah, that is because in different organizations that I've worked in, I've seen the different nomenclature, right?
Okay.
So yeah, depending on whichever place you get your job, whether they're calling it BRS or BRD is the same thing, or they're
Okay.
calling it FRS and or FRD is also the same thing as well. So let's look at requirement prioritization. First of all, can you tell me what you understand by prioritization?
Prioritization simply means putting what is most urgent and important ahead other things that one needs to do.
Awesome, awesome, awesome. Brilliant, you said. Thank you so much. So
Yeah.
prioritization, as you've said, is all about ranking requirements in their relative order of importance to stakeholders, right? Now, you agree with me that what is priority to you could be different to what is priority to me, right? Let's make it much more um, unique. For instance, if both of us are living together and you are hungry and I'm also hungry, what is priority for you to eat will be different from what is priority to me to eat, right? I might feel like, oh, let me take swallow. Let me eat curry with eba, or let me take jollof rice or fried rice. But for you, you might feel like, oh, I want to take bread and tea, right? So, what is priority or prioritization basically differs as we engage different stakeholders. I've been in a meeting whereby a department gave me a requirement they want me to implement for them. And then when I engage them, I ask them, which one do you people think is most important for us to do first? Now we have the head of the department, right? So the department is into two. We have the regulatory and operational bits of the department. The head of the regulatory bits is saying number two, three, and five is priority for us to do it like yesterday. Why the head of the operation team is saying number one, three, and four is priority for us to do like yesterday. So both stakeholders who are both heads in that same department are having differing, approach to prioritization. And that is where the job of a BA or product manager or product owner now comes in to help stakeholders arrive at a unanimous list of prioritized items or requirements that we need to do. So prioritization is the act of ranking requirements to determine their relative importance to stakeholders. There are different factors that can affect or influence our prioritization. Number one is benefits. We can decide that we're prioritizing to do this because of the benefits we are going to get or obtain in doing this. An example of benefits is revenue. We can prioritize to do item A because we know that by the time we've completed it, we are going to hit a high revenue point within a short period of time. Number two is penalty. We prioritize requirements sometimes, or things like penalty constitute as factors that influence how we prioritize a particular requirement. If we know that we are at the verge of being penalized or sanctioned by regulatory entities because we failed to actually implement or we have not implemented a particular feature, right, on our solution, we can prioritize the implementation of that particular feature or the implementation of that particular requirement over every other thing. Let me give you an example. I remember last year, we needed to implement what we call open banking in our products, and open banking is something um, that would help us that will help our customers to initiate payments or manage their accounts from another bank, right? And there was a deadline to it. If companies, fintechs, financial solutions in the UK don't implement it before October last year, you'll be penalized. So because of that, I had to prioritize the implementation of that open banking over every other initiative that I needed to implement within Q3 last year. So implementation, or should I say penalty, could be a reason why we also prioritize a particular requirement. Another one is costs. By the time we look at the cost of implementing this and realize that it's going to require a huge cost to implement this, that could influence how we prioritize it. If it's something that we've been so crazy about doing and we realize that the cost is off the roof, we can basically assign it a very low priority and look at other alternatives that would not cost us much. Another one is risk. Risk is another criteria or factor that we use in prioritizing requirements. The risk of not completing a particular implementation. There's what we call technical debt. Technical debt is more or less like um, I don't know how to put it in a much more explanatory way for you to understand. So let's say, for instance, we need to implement something like a quick fix. We need to quickly resolve something. There's an issue that came up and we need to quickly resolve it. And because we need to resolve that thing as fast and quick as possible for our customers, the engineering team might just go through a quick fix route or a hot fix route and so as to make sure that customers are satisfied, but they might not put into consideration other impacts that quick fix or hot fix would have on the solution. Now, those negative impacts that it will have are things that we call debt or technical debt, DEBT, like when you're owing something, technical debt, which the engineering team will need to later sit down and resolve or pay that debt. Now, if you realize that there's a high risk of high technical debt in implementing a particular thing, that could also decide or affect or influence the way we actually prioritize that particular requirement. Another one is dependencies. Dependencies talk about um, when things are stacked in order of implementation. Let me give an instance. If you want to eat, right, it's dependent on your ability to get up and go to the kitchen, right? If you don't get up and go to the kitchen, probably take something from the fridge or go to the kitchen to prepare something, you won't be able to eat. So even though you have prioritized eating as something to do, there's a dependency that you also need to prioritize first before you what accomplish or implement eating. Okay? Sorry, please, can you give me a moment, please?
Okay.
All right. Okay. Can you hear me?
Yes.
Yeah. So dependencies are requirements that needs to be fulfilled before we actually implement other things, right? For instance, if you want to drive, if you want to, excuse me, if you want to travel to another country, the dependency is that you need to what, get a visa, right? If you don't have a visa, then prioritizing traveling out or prioritizing buying tickets, air tickets, is like you acting in foolishness, right? So you need to prioritize that dependency of what's actually getting a visa. So dependencies oftentimes affect the priority we assign to certain requirements. And number two is time. Timing consideration goes a long way to affect the prioritization of any requirement. If you realize that a particular requirement will take us several efforts and time to implement, we can basically deprioritize that particular requirements. And another one is stability, requirements that will help our solution become stable. We oftentimes prioritize such requirements. And the last one is regulatory compliance, compliance to regulatory requirements. So if there's a requirement from regulators to implement a particular policy within our solution, we will end up prioritizing that particular requirement. A case in point or a typical example is, you know, um, when GDPR was on and there was a deadline to GDPR. Any company in the Western world, in Europe, that couldn't implement GDPR are at the verge of being sanctioned or fined or banned or whatever, right? So regulatory compliance could also be a reason why we assign higher priority to a piece of work. Since we've looked at the factors that influence um, prioritization, I think it's best for us to now look at the different ways we prioritize our requirements, which are the different prioritization technique, right? Do you have any question before we go into prioritization technique?
No, it's okay.
All right. So just to refresh, can you give me three factors that can influence prioritization with example?
Okay, we talked about benefits. What we stand to gain. We are going to gain higher revenue. Um, we talked about risk, depending on how the level of risk, if that particular feature is not prioritized over the other. We talked about cost. If depending on how much that particular thing is going to cost, if it's going to go up a lot of money, we might put it on low priority.
Okay, awesome. Thank you.
Yeah.
So let's look at different requirement prioritization technique. And we'll be looking at three techniques that are widely used in the industry. Number one is what we call the Moscow technique. People call it Moscow, right? Or Moscow. It goes by the name of the capital of Russia, right? Moscow. And
Yes.
the M there stands for must have. You see that I capitalize M, S, C, and W, right? M
Yeah.
is must have. S is should have. C is could have. And W is won't have. What this means is that any requirement we assign a must have, that requirement has the highest priority. Are you following me? The ones
Okay.
that are should have those ones are of lower priority compared to the must have. The
Okay.
ones that are could have, they are of lower priority compared to should have, and the ones that are won't have are of lowest priority. Are you following me? So you could get to an office today and they're using Moscow prioritization. So you should understand that must have, any requirement that has a must have label are the ones that have the highest priority on them. Okay.
Okay.
Now, for must have, these are features or functionalities or requirements that must be included before we can actually go live. That is, they are mostly considered as the MVP, minimum viable products functionality. They are the things that we must have before we even talk about deploying the solution for live usage with customers. While they should have are features that they are important for our go live, but they are not critical. They're also of importance to our users and they give them high value, but they are not critical. Basically, they are not critical. If we don't have them, we can do without them. Then the ones that are could have, these are features that are not critical for launch, but they are considered delighters. They can help to delight our customers, right? And then they won't have are features that have been requested but are explicitly excluded from the scope for a particular period in time. Now, the beautiful thing about, requirement management or prioritization is that what we consider to be must have today or what we consider to be should have today can become must have tomorrow as a result of all of those factors that we've just looked at. Let's say, for instance, we have a requirement from a particular solution that say one, users should be able to log into the account with their email address and password. We give that one a higher priority, a must-have priority. The other requirement says that users should be able to log in with their phone number and password. That one is a lower priority. And the third one is that users should be able to log in with their Google credentials. That one is the lowest priority. Now, if tomorrow there's a regulatory policy that says that all financial institutions should only allow their users to log in with phone number and password, it means that email address and password that is actually must have will become less prioritized, and the one that is they should have, which is phone number and password, will become a must have for us. So depending on several things, a must-have or a could-have requirement could become a should-have or a could-have requirement could become a must-have, right? And requirement prioritization is an ongoing, continuous activity that we engage in as business analysts or product manager in the course of a project. And that's because at every point in time, priorities might change, and we should be able to communicate what is priority and what is of lesser priority, right? So this is how Moscow technique goes. The ones that are must have, we label them must have. Should have, we talked about them, we should have, could have, and won't have. Another prioritization technique, which is popular, is as popular as the Moscow prioritization. In short, it's one of the most popular, is the Eisenhower decision matrix. Eisenhower decision matrix tends to prioritize requirements on the scale of urgency and importance. And this is how we humans basically prioritize things with our common sense: urgency and importance. If it is urgent and it is not important, we basically what do it later. But if it is not so urgent and it is not so important, we just give it a low or lowest priority. And then if it is not so urgent, but it is important, we give it a medium priority. A medium priority. On the other hand, if it is important and equally urgent, we give it what? A high priority. It means we need to do it what? Now. So that is how we prioritize requirements using Eisenhower decision metrics. On a scale of highest priority, high priority, medium priority, low priority, and lowest priority. These are the ways we kind of prioritize what we need to do next in a project using Eisenhower decision metrics. The last technique we'll be looking at is time boxing. For time boxing, there are three approaches to time boxing. Time boxing basically speaks to time boxing, putting our project in a time box, in a time constraint, and we don't want to go beyond it. If we say we want to deliver this project in 3 months, there is no extension. We just need to meet up with that 3 months deadline. Anything that is beyond 3 months, the project has failed, right? So time boxing, there are three approaches we can use in prioritizing requirements when we find ourselves in a time box environment. Number one is what we call the all-in. The all-in talks about including all the requirements that we need for the solution to be developed. And then we remove or postpone the requirements that will cause a delay for us, or requirements that will cause us to miss our deadline. So assuming we have, okay, so far.
Yes. Can we just Go back a little bit about this time boxing.
Okay. So
Yeah, thank you.
let me explain again. Time boxing technique is used when we are constrained by time. Let me use that word. Constrained by time, right? Just for instance, if you put a rat in a box, the rat cannot go beyond the perimeter of that box, right? Wherever the rat goes, have to be within that box, isn't it?
Yes.
Which is what happens in time boxing. In time boxing, it means that we are boxed or we are constrained by time. So if they tell us that this project is for 3 months, it means that we can't go beyond 3 months. And if we try it, if we don't deliver the project before 3 months or within 3 months, the project has failed automatically. It means everybody can
Mm.
lose their job, right? So
Wow.
when we find ourselves in such scenario whereby we are in a time boxing environment, right, or you are in a time box project, it has happened to me in the past. I made mention of a United Nations project that I did, right, at
Yes.
some point in 2020. That project was a time box. We were given 4 months to implement that project. And you know, United Nations is not a local client that you have to start messing and look for how to manage the expectation. You just need to make sure you meet up with that deadline.
Yeah.
So we make sure that it's basically the requirements that we need to meet up with that deadline that we're able to take. Yeah,
Yeah.
right. So in time boxing, there are three different approaches we can use in time boxing to manage time boxing projects. The first approach is what we call all in. All in. In all in approach, what we're basically doing is that all the requirements that we need to build the solution, we assign them high priorities. They are all importance, all in. By the time we assign them high priority, then we gather as a team and then we begin to remove those requirements that would cause us to miss our deadline. That is the all in time boxing. The other one is all out. All out means that we consider all the requirements to be of no importance, and then we only begin to select the requirements that that we believe that by implementing those requirements, we are going to meet up with our deadline and we'll miss our deadline. So all in and all out are opposites of each other. All in is that everything is considered in scope, and then we only remove the ones that would cause us to miss our deadline. For all out, everything is considered out of scope, and then we begin to select one by one the requirements that we believe would help us, the requirements we believe we can complete within the um, um, available time frame. That is the um, all out approach, right? And then the third
Yeah.
approach in time boxing is selective. Selective is all about identifying the high priority requirements, and then we begin to add and remove requirements to meet deadlines. So in selective, what we do is that the ones that are highest priority, you identify them. Then the other remaining requirements, will begin to add or remove them in order for us not to miss our deadline. That is what the selective approach. Please, can you give me just two
Okay.
minutes or
All right.
less? All right, I'm back. Can you hear me?
Yes, welcome back.
Hello? Okay, thank you. So that is how the selective approach basically works, right? So in time boxing, we have all in, all out, and selective. Okay, now that takes us to the last section of today's class, which speaks to requirement attributes. We'll look at documentation formats another day, but let's talk about requirement attributes. Or can we look at it today if you have time? But before we go into that, do you have any question regarding the techniques I just talked about now?
No, I'm okay.
Okay.
Yeah, thanks.
I also realized that you guys are not listening to the recording. I checked because
Yeah,
it's only you and Fitz that have access to the recording.
yes, I
Oh,
started listening to the last class. I only missed the beginning part a little bit. So I listened to that part yesterday night.
okay. Please and
Yes.
please, I'm encouraging you guys to please. It's not easy, but please,
Mm,
the passion that you had in you when you made
okay.
the decision to take this course,
Mm,
please reignite that passion within yourself and use
okay.
that passion to listen to the recording. This is
Okay.
very important. It's what is happening to you is normal with us human beings. It's normal with us. As I am today, I'm taking a particular course online. Do you understand? I take
Okay.
a with how busy I am, I also take a particular course. And the tendency to say, I'm so tired, I can't listen to recording. And sometimes I miss classes too. I've missed like almost 2, 3 classes in the course I'm taking. For it all requires discipline, right? Even
Yeah.
though it is just to deprive ourselves 30 minutes or 1 hour and use it to take a look at the recording, it will
Mm,
go a long way. Like it will go a long way in helping you. There's something when I was in university, there was something my one of my advisors told me. He told me that yes, one way to actually excel in academic work is to make sure that when you finish a class, you don't stay beyond 24 to 48 hours before revising that class. So
mm,
when you go to class, you take notes. After the lecture, when you go back to your hostel, don't stay more than 24 to 48 hours without revising what you jotted down on your notes. That when you revise that particular thing within 24 to 48 hours, it sticks better than when you wait for maybe 3 weeks to now prepare for exam or thereabout. It sticks better. You understand it better. And if there are different things you need to know, you can go to the library and get more clarity on that. So,
mm. Very
you know,
true.
listening to recordings is a form of revision and it helps you a lot. So please, if it is 1 hour of your time, or just say, I want to be dedicating 1 hour every day to everything business analysis, it will help you a lot. It will help
Mm.
you a lot. Okay. Now,
Okay, thank you.
you're welcome. So, requirement attributes. What it basically speaks to is characteristics of requirements or qualities of requirements. Requirement attributes help us to describe the guidelines for evaluating the quality of requirements we are writing as business analysts or as product managers or as product owners. And that is because if our requirement is not of good quality, if the quality is poor, we will misrepresent things to the engineering team. So we need to make sure that the requirement we are writing is of good what quality, right? We'll talk about the invest evaluation tool for user stories, which is independent, negotiable, valuable, small, and testable, as well as estimable. But today we'll look at other evaluation tool that we use as well. I call this takupt, right? I call it takupt. Basically, people don't call it anything, but because I want students to kind of remember these things, I understand. I know that using acronyms will help people to remember things better and for a longer time. So I call it takupt. So we'll start by looking at this takupt. Number one is testable. Number two is atomic. Number one is uniquely identifiable. Number three is complete. Number four is traceable. Number five is consistent and unambiguous. And the last one is prioritized. So we'll take a look at them one after the other with examples. And we'll be taking a look at them by considering an e-learning solution. So just work with me on this. So let's imagine an e-learning portal or e-learning solution that students will need to go on there to register, right? And not just registering, lecturers will also need to go there to what? Log in. Students will need to go there to take their courses, right? So let's imagine that e-learning solution, website or web application or whatever, right? And we're going to look at different ways of writing bad requirements versus writing a good requirement, okay? So let's start with a bad requirement. First one is requirements should be atomic, right? That is the first attribute we're looking at. For atomicity, we are basically saying that the requirement should be at a very low level of details, and it should not be possible to be separated out into components. That is atomicity. Now, here's an example of a bad requirement. Students will be able to enroll to undergraduate and postgraduate courses. The issue here is that we're talking about students enrolling to undergraduate and postgraduate courses. But if you look at it, there are different course track. Undergraduate courses are different from what postgraduate courses. The kind of students that enroll to undergraduate courses are different from the kind of students that will enroll to what postgraduate courses, right? So a better or a good requirement would say students will be able to enroll to undergraduate courses. That is a separate requirement. And you also separate the one of the postgraduate to say students will be able to enroll to postgraduate courses. Another requirement attribute is being uniquely identifiable. Uniquely identifiable. This speaks to requirements having a unique way to be identified. If you remember when I wrote my user stories last week, let me open it again. You can see that this is what we call RAC-2. This is a unique ID for this particular requirement. Another one is RAC-29. This is a unique ID for this particular requirement. So Jira automatically helps us to solve this, right? Jira helps us to solve if you're using Jira or Azure DevOps. But if you find yourself in a situation where you're not using Jira or Azure DevOps, and you're using things like Microsoft Word to write your requirements, or spreadsheets or PowerPoint to write your requirements, you need to make sure that you uniquely identify your requirements with IDs, right? See this example. Students will be able to enroll to undergraduate studies. Students will be able to enroll to postgraduate studies. This requirement satisfies the atomic criteria, but it fails the unique identification criteria. So the better way to uniquely identify this is to say courses 1.1, students will be able to enroll to undergraduate courses. 1.2, students will be able to enroll to postgraduate courses. In this way, we have uniquely identified the requirement. And at any point in time, we can make reference to this requirement and say, let's look at requirement 1.1. What does requirement 1.1 say? Or what does requirement 1.2 say? Right? In that way, we know that the requirements have a unique identification. Another attribute is complete. Our requirements need to be complete and concise. A typical example of an incomplete or unclear requirement is a professor user will log into the system by providing his username, password, and other relevant information. Now, if I ask you, what would be the other relevant information they need to provide? Do you have an
It
idea?
can be anything.
Can be anything, right? So you are
Yes.
creating confusion because your requirement is not clear enough. So
Yeah.
when writing requirements, we must ensure that the requirement is clear and concise. It is complete. An example is this. A professor user will log into the system by providing his username, password, and department code. This
Yeah.
is concise. This is clear. This is complete for engineering guys or whoever is looking at the requirements to understand and implement, right? The next
Mm.
one is that our requirements should be traceable. Our requirement should be traceable. And for requirement being traceable, it means that we must have properly assigned ID numbers, identification numbers to our requirement, like we mentioned, our requirement being uniquely identifiable, right? It means that we can trace a requirement from the child to the parents. An example is this. Let me go back to Jira so you see. You see here, this is a user story. Continue with Google, right? If you say what? Parents. The parent, which is the epic, is what? Reviewer onboarding. So we can basically trace this requirement to its parents' requirements, right? So when you are writing with Jira or you are writing with your Word document or spreadsheet, you must ensure that your requirements are uniquely identified and they can be traced to either a parent's requirement or a child requirement. Okay. Now, the next criteria is that our requirements should be prioritized. We just finished talking about requirement prioritization. It makes no sense for you to write a requirement and everything have the same level of priority. It is inappropriate. When you write requirements or when we write requirements, they must and they should have different levels of priority. Let me open this backlog and show you here. So when I open this backlog, so let the requirements in this backlog open. Now you see these ones with double arrow up, they are highest priority. You see, if you see here, you see highest, right? Can you see highest
Okay.
popping up?
Yes.
Right. So all of them don't have the same level of priority. See these ones? You see you see what low. The ones that are
No.
low priority are these. The ones that are this one, they are what medium priority.
Okay.
So when you write your requirements, you should be able to assign a priority so that it is clear to everyone the ones that are of high priority, highest priority, medium priority, low priority, or lowest. I can come here to change the priority of this requirement by clicking on it. I see, do I want to make it to become highest or high or low or lowest? Okay.
Okay.
So we must make sure that our requirements are well prioritized. We don't just assign requirements the same level of priorities, right? For instance, register student is of priority 1, maintain user information is of priority 2, enroll courses is of priority 1, view report card is of priority what? 3. So assigning the appropriate priority to our requirement, and we just finished requirement prioritization. In arriving in this priority, it requires collaboration with stakeholders for everyone to be aligned on what is priority and what is not what priority. Then another attribute is that our requirement needs to be consistent and unambiguous. Our requirement needs to be what? Consistent, both in terminology and in the context or background we are trying to communicate. Look at the example of a bad requirement that says a student will have either undergraduate courses or postgraduate courses, but the student cannot have both. It means that the student needs to have just one, isn't it? Instead that the student has undergraduate or the students have postgraduate. But then we now have another requirement that says that some courses will be open to both undergraduate and postgraduate courses. I mean, students. What this is trying to say is that the first requirement says that a student can only pursue either undergraduate or postgraduate. A student cannot pursue both, right? But the
Mhm.
second requirement, maybe we now wrote this requirement later on in their requirement specification and we've forgotten what we've written before. And we now say some courses will be open to both undergraduate and postgraduate. But basically saying that some students will have access to both undergraduate and postgraduate. So this contradicts the previous requirements we have written and it creates ambiguity. It is not consistent, right? Or maybe in your requirement, you're using the terminology student. And then at some point you begin to use candidates. Then begin to use users, customers. You are not consistent with your terminology. If the role or the end users terminology is student, make sure you maintain student for that particular actor or true whenever you are talking about that particular actor in your requirements. Okay. So here's an example of a good requirement. Good requirement is basically sticking with one requirement that you've written and being consistent with it. Another example, which is the last attribute that I'll be looking at today, is our requirements being testable. We need to ensure that the requirements we are writing are testable against some given criteria. Just as we looked at user stories and use case specification, For use case specification, we have business rules that we use to test the use case, right? And for user stories, we have the acceptance criteria or the getting syntax that we use to test it to make sure that it meets or satisfies user expectation. Here's an example of a bad requirement. This one says each page of the system will load in an acceptable time frame. What is this acceptable time frame? Is it 5 minutes, 5 hours, 2 seconds, 3 seconds, right? As a
Yeah.
BA, we need to make sure that we write reasonably testable requirements for the engineering team to implement. An example of a good requirement would be this: register students and enroll courses pages of the system will load within 5 seconds. It means that when a quality assurance or a tester, a software tester, picks up these particular pages to test, if if it loads after 5 seconds or 6 seconds or 7 seconds, it means that the implementation was wrong. They'll raise it as a bug, and engineer will need to fix. Okay, so our requirements needs to be testable. When we are writing them, we should need to test them against some given criteria. Let me quickly go through. Okay, we'll look at that later. That is requirement. Okay, let's take a look at it today. We still have time, right? Let
Okay.
me. Yeah, let's take a look at requirement documentation. We're basically looking at two documentation formats. Yeah, two documentation format that I'll be looking at today. Come on, let me see if I can get it. Okay, I've passed all these. Come on. Hmm. So documentation formats. They are basically two documentation formats we'll be looking at today. Number one is business requirement document, BRD. Some people call it BRS, business requirement specification. Now, the essence of a BRD is to help define the requirements of a business process and also the goals of the business. The BRD contains requirements that needs to be met and fulfilled by the system for development. The BRD basically communicates what the system must do in order to fulfill the requirements of the business. Let me show you a template of a BRD on my website, on the Optrust website. So let me go to optrustdigital.com. optrustdigital.com. Look at it here also. Why is this taking time to come in? All right, it's loaded. And it loaded very fast here. I don't know why it's taking time to load on another browser. So let me know when you can see my screen, okay?
Yes, I
So
can see.
when you come to the Optrust website and you go to resources, you go to templates, you see business analysis resources. So this is a BRD template,
Okay.
right? Once you open it, okay, it's downloaded automatically. So I prepared it and I put it in my website so to be available for everyone to see. So this is a typical example of a BRD template, right? We have the
Okay.
introduction, the title page, okay? Then we have the preambles where you talk about the owner of the document, document reference. We also have document revision history, which shows the history of activities that have occurred on these documents. Then document approval, and that is the beauty of BRD. BRD is one of the documents that we use in gaining approvals. I know you, there was an example that I made mention about. I went to that's health solution that I went to the hospital. That was my early time. I couldn't elicit requirements. I just prepared something and then we went beyond timeline, deadline rather. Sorry, we implemented something that was out of scope and we needed to start the work again. Do you remember that example I gave? Now,
Yes.
the beautiful thing is that BRD helps us to mitigate such things. And that's because when the BRD is completed, you, the BA, will need to share the BRD with stakeholders. After they've reviewed, you request for them to approve. So they have to sign. Once they approve, it means that whatever thing it means that tomorrow, if they say that what we've done is not in line with what they wanted, we tell them, but you guys are the one that approved these particular requirements, isn't it? So this is the document approval section of the BRD. Now we have the contents, table of contents page, and then we have the introductory page. Oh, why are these things aligned this way? These things ought to be left aligned, not, let me enable editing. They ought to be left aligned, not center aligned. Oh, oh really? It ought to be left aligned. Control L. All right, let's just go ahead. Let me pull up the one that is on my laptop. Um, and pull up the one on my laptop. Okay. So this will not take time. Mm. BRD. Okay. Let me open this and see. Same thing. Why? Okay, let me use this one. This one would work. Where is it? It wasn't FRD. This one will be better. Let me use this one. Okay, better. Yeah, this is better now. So this is the one I also use for training. I prepared for the eVote solution I used to talk about. So we have the documents, the introduction section, where I talk about the purpose of the documents. We define what the solution is all about. We state the business objectives, right? The intended audience, that is the audience for this BRD. BRD audience is mostly the business stakeholders. So you mention them out there. You talk about the current situation as is. That's the current business process. If there's no current business process or there's no current way that that particular business process, that solution we're trying to implement, there's no current way that it is done, we basically say the current process is not available. Then the envision is how the solution would work or what the solution would do, right? Then scope is where we list out a list of items, outline the items that are in scope. The ones that are out of scope, we mention them, or we basically say that any item that is outside the above outlined documented items is considered to be out of scope. Process attribute is where we look at the critical success factors and how we are going to measure those critical success factors. Example here is the solution must be accessible over the web, right? And to allow eligible voters participate in the election process. So how do we measure that? You state it. Another one is that only eligible voters should be allowed to log in. How do we measure that? You state this. Another one is the solution should be 99% secured. How do we measure that? You state it. So as much success criteria, critical success factor rather, and key performance measures, you state them and indicate them. Then you have process ownership. Who owns the process? Is it the client that owns the process? You indicate the client. If it is your company that owns the process, you also state it, or which department. Key controls, how are we going to control implementation? These are basically done with the use of quality assurance. So this one is more or less like a, a default statement here, right? Then stakeholder requirements, actors and functionalities. You talk about the actors, or should I say users. We have super admin, EMC, eligible voter, like we're giving. And what are their functions? What functions would they be performing? You state those functions here. Now, the key features of the solution: login, system configuration, user management, election management, casting of votes, password resets. And then we now have our HLRs, high level requirements. And this is where I talked about your requirements being uniquely identifiable. You see, HLR 001, HLR 002. So these are the unique IDs for the requirements, our high level requirements. And they need to be prioritized as well. These are the priorities for each and every one of them. So if the solution have 50 requirements, you write it out as required. Then we have our process model. We are going to learn this process model next week, Wednesday. This Saturday, we'll be learning use case model. So next week, Saturday, we'll learn process model. So you include your process model, and then you state your risks, assumptions, and dependencies that you have identified. This is for BRD, business requirement document. The next one is FRD. And for FRD, what we are basically doing, or what we're basically saying, is that we are much more concerned on how the solution will be implemented to satisfy the requirements and functionalities that we have outlined. We are talking about the functional requirements of the solution. That's what it's called, functional requirements document. And here is a sample functional requirement document for the same e-voting solution for IIBA, right? So let's go. We have the usual preamble pages. I call them preamble: document approval, revision, information, and whatnot. We have the table of contents. Then we have the introduction. We have the, let me zoom this a bit. Is it better now? So we have the introduction. We have the purpose of the document. Can you hear me, Zofa?
Yes, I can.
Okay. We have the solution description. We have the business objective, right? We have the solution scope. We have the current and to be process. We have the key indicators. These are basically more or less like what we had in the initial section of our BRD, right? We have the key controls. We have the stakeholder requirements, which talks about the users and their functionalities. Then we now begin to go into more detailed things. So below are the list of requirements provided by AMC. So stakeholder requirements. So we state the requirements that were provided, and then we now put in our requirement models, our use case model. We write our use case specifications. US 001, we write each and every one of them. For each use case specifications, we draw our process model. The next use case specification, we write it and draw our process model. So if there are 20 use case specifications, we write all of them and draw process models. If there are 100, we write everything and draw your process models. So let me just scroll through. We've already learned use case specification in class. So the next thing we'll be learning in class will be modeling, use case modeling and process modeling. That's what we'll learn in the next two classes,
Okay.
right? Yeah. Let me just scroll down out of this side. Then once we're done, we talk about your project dependencies. Then your non-functional requirements, you state them: security, and if you identify security requirements, reliability, performance, all of those non-functional requirements, you outline each and every one of them one after the other, and that is it. So these are the two requirement documentations that we have in business analysis. For product management, we have product managers or product owners don't write BRD or FRD. What they write is PRD, product requirement document. So let me see if I have one here. It will be my office laptop. This is my personal laptop. So let me see if I have a PRD here. Okay, let me see if I have this here. So this is a product requirement document. So you have the preambles pages where you talk about version, release, design, who is working on what, and what's the view. We have the version control. Then we have the introduction, the purpose of the product of the document, the scope of the features, definition of acronyms, objectives and goals of that particular product, right? Then the user stories, the high-level user stories, you basically put them, and then the functional requirements, you state the functionalities for that particular product. Once you are done with the functional requirements, you also list out the non-functional requirements, and then the usability, then the project assumptions and dependencies, the acceptance criteria, appendix, and then that is the end. So that is how the PROD goes. There's nothing more, there's nothing less. The only difference with this is that there's a section that is called, there's a section that you include the screen, the design, that's the design of the products. You also include it in your PRD. So that is it with requirement documentations that we have, both in products and in EA.
Wow, that's a lot of information.
Yeah, I
Definitely
don't want
have
to take
to
it,
play
but
this
I saw
again.
that we have. Yeah, you can listen to the recording if you have any questions. Because the fact is that when I know that people are not listening to recordings, is when you don't ask me questions often. When you
Mm,
ask questions and you do research, you have questions. What are the question is not that what I said is wrong, but you want to
mm.
better understand based on
Okay,
what you are seeing
right.
out there. Do you understand? Because
Okay.
there's a way I'll say something, and how maybe a website you visited will say it might be different. So you ask me questions to clarify to you. That's why I know that people are not listening to your recording.
Okay.
All right. So I will extend the class, I mean the submission of the assignments to Friday. Please, please, and please, all assignments should be turned in on or before Friday. Please.
Okay.
Very
Okay.
important.
All
Please.
right. I'll do
I've indulged you guys a lot and enough. And I don't want to indulge you again. So
that.
please,
Okay.
all assignments should be submitted on or before Friday. I won't give you guys any assignment until you've completed those two assignments.
Okay.